Hey guys, okay, I'm gonna try a different website for notes. I'm gonna try to use Siteboard. Hopefully it'll make a little bit nicer. It's nicer to write on and it's got a little bit more space. I thought I would just leave the camera on just for the beginning part because I wanted to tell you that this particular bit of notes is about um, the difference between functions and relations and the beginning and start of discussion of domain and range. Um, Regarding function and relation, it's it's just a concept that you have to kind of change the way you're thinking. And it is kind of a big one. I mean, it seems simple in so many ways, but it's really not. So it's really kind of like a mindset change. So let me try to explain. So for me, a function is relatable as a marriage. Um, so like, okay, let me explain. So in the beginning, um, or the way you guys have done graphing so far is you have your X and your Y axis, right? And then this was Y, this is X. Okay, and the idea is that say you have a line like this. Okay, you get your X and your Y, and it's crooked, whatever. Okay, and you put in, say, 0, 0, and 1, 3, 2, 6. So 0, 0, 1, 1, 2, 3, right? 2, 6, 3, 4, 5, 6. So the idea is that you graph this line. Okay. And the way that we've done these lines so far is it feels very beginner in the sense that it's like, okay, I graph my points, whatever, but you're not really thinking about it as a function. It's a little different. So for me, okay, I said it reminds me of my marriage, so or marriage in general, not mine. But the idea is that so before I got married, I had a name, like my own name, okay, and people called me by my own name, and so it feels a lot like Y. Like Y has a name, X has a name, okay, Y equals X, 3X, and you kind of think of them as almost separate kind of things. When we change to f of x, that feels a lot to me. F of x equals y, by the way. Okay, that feels a lot to me like when you get married and you change your name. So I got married and I changed my name. And then here's my explanation of function. So f of x, okay, is basically the function of x. So, for example, when I get mail from Pius, my husband works at Pius, I get it addressed to this. I am nowhere in that sentence. The only thing Mrs. means that I'm attached to him, and this is his name. I am being defined by him. You don't know who I am. You wouldn't know who I am. I wouldn't have an identity if you didn't know who he was first. Agreed? So it's kind of the same way with a function. Okay, a function is a way of thinking that f is dependent on x. We don't really know what f is until we know x. It's kind of like the idea of a function machine. So if you have this machine, okay, I don't know why I drew this. I don't know how to draw a machine, you guys. Here, this is like a little spoke wheel. I don't know. This is a machine, okay? And we input x into the machine and it spits out the function of x. And the name of this function is f or f of x. It doesn't matter. They're kind of interchangeable. We typically will erase y, okay, and we now call it f of x. Or we could call it f, okay? It could be either one, okay? The idea is that we're looking at that we put in an x and we get a y. Okay, we put in an x and we get the function of x. So we don't know about the function until we know about x. In other words, the way we think of it in a graph is more like, okay, so oops, no, stay there. Okay, stay there. Like why in the world? Stop that. Okay, so you go along the x-axis. Okay, that's the input. You walk along the x-axis until you're at a point, and then you go, hey, where am I? On the y, and you go down this distance, and this location right here, that is the f of x. That's function of x. That's your y. This distance right here is the value, this distance, which is still the same thing. It's still y, but you're starting to think of it a little different. This is the value of the function. Okay? So there's a couple things you need. You need to know that the value of the function equals y. I'm going to write that in red. Okay? When they ask you for the value of the function, they are asking you for y. That's all. When I say function, you say y. Function, y, function, y. Okay, it's like a cheer. Just remember that. The value of the function is y, not x. It's never x. The value of the function is never x. Okay, so the value of function is equal to y. F of x is equal to y. Okay? The value of the function is the distance, okay, from the x-axis. And I should have put that somewhere. Let me write that. Okay? The value of the function is equal to y, which is equal to the distance from the x-axis. Yeah? Okay. That's really important because it's a frame of mind change. It's not like x and y. It's now like x shoots to y. So it's a little different. All right. Okay. I'm going to take a look at the next three topics, and they deal with how to tell the difference between a function and a relation. Okay. A function has a one-to-one relationship, and I think I'll put that here too. A one-to-one relationship. And I'll explain that on the next one. So camera off. Let's go ahead, go here. Okay, it says for each relation, decide whether or not it is a function. Okay, so here's the idea of a function. If we input x into this machine and it spits out f of x, it is a function if it is a one-to-one relationship. Okay, basically anything is a relation. Okay, so in other words, like you have so many relatives and stuff, you have a relation, they're related to you. Anything you graph basically is a relation. Anything you plot is a relation. Anything you put in a table is a relation. It's describing two things and how they relate. But the one-to-one relationship is unique, and that is the definition of a function. Okay, and what does that mean? It means that when you put in x, you only get one y. Okay, now that can get a little confusing because look over here. Ready? Take a look. You've got your domain, which is your x. You've got your range, which is your f of x or y. Okay, and you can keep writing both of them until they sort of click, until you're like, oh yeah, functions y, functions y. Okay, I got it. All right, take a look at the domain. Read it out loud and listen. H, J, N, S, B. We have not repeated anything twice. So really, we don't really care about the range. To be honest with you, we don't look at the range. It doesn't matter. It really doesn't matter what gets spit out. What matters is that we only have the input going in once. Okay, so in other words, if I were to put in H, whoa, how did I get in here? Let me get back to the pen. Okay, if I were to put in, say, H into this function and it spit out K, let's just say that happened. Okay, and then I inputted H again, and I don't, okay, sorry, just take a step back. I'm listing it twice. If I put in H again and it spits out an M, notice Okay, yeah, these are unique, but look, I inputted H twice. I could rewrite that like this. Oftentimes they list them twice, but I could actually write it like that. Can you see that it has two values? In other words, when we inputted the H into the function machine, it spit out two values. That is not a function, not a function. So don't look at the Y's, don't look at the outputs because they can be unique. They can be the same, they could be unique. What you need to look is for a repetition of the input. And in here, there is no repetition, so it is a function. See, it doesn't matter that they spit out B. You can have everything, A, B, C, D, E, all of these could go to the same value and it wouldn't matter because they only have one output when you put them into the machine. Okay, take a look at this relation. So just look at the domain. Don't look at the range. 7, 8, 4, negative 7, 7. Okay, see? You repeated 7 twice. That can't happen. That is not a function. Because one time I put it in the machine and I got sky. Another time I put it in the machine and I got lake. That doesn't work. You can't have two values. Okay. Next, let's look at the x, only the x. Okay, so we're going to go with 8, 0, negative 6, and 5. I didn't repeat anything, so it is a function. How about here? Z, R, J, M. Nope, I didn't repeat anything. Just keep your mind focused on the input, not the output. Pay attention to the domain and the x value. That's what we need to look at. Okay, next one. The next one is the vertical line test. This is a test that we can use to be able to tell whether or not something is a function. Because, look, if we're in a graph situation, okay, and I walk along the x, okay, say I walk along the x to 3. I walk to 3, and I go, oh, and you go, hey, and here's another little trick. If you want, it really helps to start thinking of the graphs as like roller coasters or roads or things that you can get on, okay, like hills or whatever. So say I go to 3 and I go, okay, now jump on the graph. Okay, and let's say the graph looks like this. Okay, doesn't really matter what it looks like. Okay, here we go. I say, go to 3. And then I say, go to the graph. Well, crap, you gotta go up this way. Hello. You gotta go up this way till you get here. And then you also have to go down this way to get here. You cannot have two values. So this is not a function. And this is why the vertical line test works, because you're hitting it twice. You're hitting your x value twice. Remember the vertical lines? This is like x equals 3, right? It's not important. I just want to remind you. So basically we drew a line, x equals 3, and there are two values. Okay, can't have that. So let's take a look at these. Okay, so vertical line, vertical line, vertical line, vertical line. If you can hit 2 points at any one point, it's not a function. I couldn't hit 2 points. This is a function. Okay, draw lines. I cannot draw a vertical line and hit more than 1 point. So this is a function. Take a look at this one. I draw the lines. I'm not hitting. Oh, but what happens here? It's actually a function because remember the open circle means it doesn't reach that. So this is still a function, even though they're lined up. I didn't actually hit that second point because it's empty. That circle is an empty circle. Okay, come here. Nope, not a function. Okay, and I don't know, I think I might have moved this a little bit. Come up here. No, I didn't. I just cut off the picture a little bit. Okay, so this answer is no. Take a look here. Okay, works. Right here. Take a look. Right through here. Not a function. I hit 3 spots. There's 3 values for the x equals -1. It's -1, 2, -1, 5, -1, -5. So nope. Here. I hit it here and I hit it here. So nope. Okay, not a function. Next. And this one's about domain and range. Okay, so Domain has to do with your X and range is your Y. Okay, and we'll say Y or f of x, but really we think of it as Y still. So keep thinking that, right? Okay, both. They both work. So we're just looking at the X for domain and f of x or Y for range. So let's look. -7, -5, -6, 4. Basically, for the domain, what they're asking is what would you put into your function machine? What would go in? And you use these brackets, and that's kind of an ugly one. Let me try that again. Okay, let me try it again. I actually remember learning sets in seventh grade and or eighth grade, and I remember practicing these little brackets because I wanted to make them pretty. I don't know why I have that memory. I can't remember anything else in my life. Anyway, -7, -6, -5, and 4. Now, why did I list them that way? Oops. Why did I list them that way? Because we always list them in order from least to greatest. So a lot of times what people do is they take them out first. -7, -5, -6, and 4. And then they go, okay, let me rearrange them in order. Okay, so range. Same thing with range. Let me grab some. Okay, so range. Range is the Y. And you do the exact same thing for that. Okay, so our range is -7, 8, 0, and -6. And it doesn't matter we're not pairing them. It doesn't matter what they were matched up with. We're just listing the values that were put in and the values that were spit out. Okay, the least value is -7, -6, 0, and 8. And that is it.